Hello all, I Dr. Sarika Panwar welcome you all in the video lectures of machine learning. Today we will start with Bayesian learning. Bayesian learning is very important concept in machine learning which is very frequently used for the prediction. For Bayesian learning, conditional probability is very important. So this is probability of A by B. It means if A and B are two events, then probability of occurrence of event A given that B has already occurred is the conditional probability A by B. That is equal to the probability of the intersection of these events A and B divided by probability of B. Similarly, it can be defined as the probability of B by A. So now in this case, the probability of occurrence of event B given that A has already occurred will be equal to probability of B intersection A divided by probability of A. Now say these both numerators are same. We can write probability of A intersection B or probability of B intersection A. So if I try to equate the equations 1 and 2, so from equations 1 and 2, if these two numerators are same, and we can take this particular probability of B at this left hand side and this probability of A at this left hand side in this equation 2. So with this concept now we can equate equation 1 and 2. So now it will become probability of B by A into A, probability of A is equal to probability of A by B into probability of B. So by equating these two equations, now what we can get? We can get the equation to find this probability. Probability of A by B will be equal to probability of B by A into probability of A and divided by probability of B, because this term will go as the denominator of this one. So now this is actually the Bayes theorem. This equation is nothing but the Bayes theorem, and this theorem is used for the Bayesian learning. So we need to remember this particular equation because we need this equation very frequently in Bayesian learning. So in this equation, this probability of A by B is called as the posterior probability. Then this probability B by A, it is a likelihood. This is prior probability, and probability of B is called as the marginal probability. These are the frequent terms which we come across, like likelihood, prior and marginal probabilities. Okay, and this is the posterior probability. So we find the posterior probability with the help of likelihood, then prior probability and marginal probability. So what is Bayes theorem? Actually Bayes theorem is a foundation of Bayesian learning. With the help of Bayes theorem, Bayesian learning is done. So in the Bayesian learning, what we do? We find the most probable hypothesis. We find the most probable hypothesis given the data. Given the data, we find the most probable hypothesis plus any initial knowledge about the prior probability. Means we will be given with the data, that is our history or the experience, and we will be given with the prior probabilities. With these two terms will be given and we find the most probable hypothesis. So with the help of this Bayes theorem, we find this probability of hypothesis given the data D. So that is important. See, if we want to find this probability of the hypothesis function H, then we should have the data given. So if with the data given we can find this probability. So for that what we need, this is the likelihood, this is probability of hypothesis, that is the prior probability, and this is the probability of the data. So what these terms are called as? In Bayes theorem, these terms are nothing. This first term, this which we calculate, is the probability of hypothesis given data. Then this is the probability of data given hypothesis is true. This is probability of hypothesis before considering the data, that is the prior probability. And this is the prior probability of the training data. So if we know that in machine learning, every algorithm we try to learn based on the past data. Whatever data set we are available with that data we train our model, and we try to come up with the best model. But now in this Bayesian learning, we we select the best hypothesis based on its probability. But what is the prior requirement? Data should be given. If the data is given, we find the probability of the hypothesis, and we select the most probable hypothesis, the one whose probability is highest. Out of, let us say, 10 hypothesis function, we will select the one which has got the highest probability. So that is nothing but the Bayes theorem, and based on this Bayes theorem we do the Bayesian learning. So P of H, it is the prior probability of hypothesis H. P of D is the prior probability of training data D. P H by D is the probability of H given that D, that is the posterior density, and probability of D by H is the probability of D given the hypothesis. So that is likelihood of the data given that hypothesis is there. Okay, so this is all about the Bayes theorem. So based on this Bayes theorem we will try one numerical. So we have to find the probability of getting the king given that it was a face card. This is very simple problem which we frequently come across in probability theory. So we have to find the probability of getting the king given that it is a face card. Okay, so for that we will have to use the Bayes theorem. Bayes theorem is nothing but probability of H by D is equal to, here it is probability of D by H into probability of H divided by probability of D. Okay, so here our H is king and D is face. Okay, so it is given that it is a face card, we have to find that what will be the probability of getting king. Okay, so we know all these probabilities. We know the probability of getting the face card given that it is a king, it will be 1. If it is a king card, then definitely it is a face card, so the probability is 1. Here what is the probability of getting the king out of 52 cards? It will be 4 by 52. And what will be the probability of getting the face card? There are 12 face cards in out of 52, so it will be 12 by 52. Okay, so we will put these values. So probability of getting the face card given that it is a king is 1, that is 100% probability. Then what is the probability of getting the king out of 52 cards? It is definitely 4 by 52. Why? Because there are 4 king cards out of total 52. And what is the probability of getting the face card out of 52? It is 12 by 52. Why? Because there are total 12 face cards in our 52 total cards. Okay, so with this calculation now we get the answer 1 by 3, 0.33. So probability of getting the king given that it is a face card is 1 by 3. So we have solved this problem based on the Bayes theorem. Okay, so now we will solve this numerical also based on Bayes theorem. Say what is given in this numerical? A patient takes a lab test and result comes back positive. The test returns a correct positive result in only 98% of the cases in which the disease is actually present, and the correct negative result in only 97% of the cases in which the disease is not present. Furthermore, 0.008 of the entire population have the cancer. The lab test is about the cancer. So we have to find the probability that this patient has a cancer, and B is nothing but the probability that the patient does not have a cancer. So how to do these calculations? And see, in such numericals we have to first understand what is given in this problem. Now what is given, the cancer test returns a correct positive result in only 98% of the cases. What do you mean by correct positive result? If 100% patient do the test, then out of those 100%, only 98% get the correct positive result. Means positive result means probability of getting the positive result given that it is a cancer. That is the correct positive result, and that is given as 98%, 0.98. So if this probability is given, then easily we can find the probability of getting the negative result given that it is a cancer. So it will be the wrong prediction. So probability of getting the negative result given that it is a cancer will be 1 minus 0.98. So it will be 0.02. Next, what is given? That the probability of getting the correct negative result is only 97%. So if 100% people do the test, out of those 100%, only 97% gets the correct negative result. So correct negative result is 0.97. That is the probability of getting the negative result given that the cancer is not present. That is given as 97%, that is 0.97. So what will be the wrong prediction in that case? That is the probability of getting the positive result given that it is not a cancer. It is 0.03. That will be 1 minus 0.97. So it comes out to be 0.03. So based on these two, 98% and 97%, that is the probability of getting the correct positive result and probability of getting the correct negative result if it is given. And then we can find the probability of getting the wrong result for positive result and negative result, and that we have calculated 0.03 and 0.02. So we need to understand what is given in the problem. This is actually the fact given, that 0.008 people have this cancer. So probability of cancer will be 0.008. So probability of not having cancer will be 1 minus 0.008 will be equal to 0.992. If all these terms are known to us, then we can easily find out the probability of having cancer given that the test will be test is positive, and probability of not having cancer given that test is positive. We can find both of these terms. Okay, so for finding the probability of having cancer given that the test is positive will be equal to probability of having positive result given that it is a cancer multiplied by probability of having cancer divided by probability of positive result. Okay, now what is the probability of not having cancer given that it is a positive test? It will be equal to probability of getting the positive result given that it is not cancer multiplied by probability of not cancer divided by probability of positive result. Now in this equation what we observe, we don't know this term probability of positive, and in both the cases the denominator is same. So by though we don't know this term, once we put all these numerator values and if we compare, if both are same, then based on these values we can find that which one will be higher. Okay, so what we will do now, we will put the values. Put probability of positive given it is a cancer is 0.98 multiplied by probability of cancer is 0.008 divided by probability of positive result which is not given to us. So it is 0.00784. Now probability of not cancer given that it is a positive result will be equal to probability of positive result given that it is not a cancer. It is 0.03 multiplied by probability of not cancer, it is 0.992 divided by this unknown parameter, that is probability of having the positive result. So that is equal to 0.0298 divided by probability of positive result. So now if we compare these both terms, what we observe, if we put, if this P plus is same, Okay, and that will be same na. If this is for this we are solving for the same problem, then this term will be same, and if this term will be same, and if we put that value, then which one will be higher, which probability will be higher? The probability of not having cancer given that it is positive will be higher value. Why? Because it is 0.0298 divided by p positive, and it is 0.00784 divided by positive. So definitely this will give the higher value. Okay, so the probability of not having cancer given that the test is positive will be the higher, so the patient is most likely does not have the cancer. So this is how we can solve the problems based on the Bayes theorem. If you like the content of this video, then please subscribe to my channel and like my video. Thank you.